A very good day to I are Awang bin Taib and I are Nikmat Nikoden. My name is Vigan Lucky Stephen Susay, metric number AA2020, and today I would like to present about my research, which is on about classification and identification of type of feed using color code of NICS color sensor. This is the important research outline of the research, which is introduction, problem statement, aim and objectives, results analysis, conclusion, and recommendation. Let's talk about the introduction for this research, which is peat is the top layer of the organic matter in a soil that is largely made up of partially decomposed plant matter that has accumulated due to waterlogging or often soil is excessively acidity and nutrient deficit. The importance of this classification and identification of peat soil is not given in the field of engineering, but new peat discovery gives new findings in the field and for the development of place. Thus, we have approached to classify and identify peat soil using NICS flow color sensor, using color code, and also coding with the help of Excel spreadsheet. Let's talk about color. Color may be a helpful signal of some soil characteristics in general, as well as some chemical activities going on below the surface. Soil classification was done by using Munsell color chart, which is a conventional method in the old days, and it is a standardized color code to identify what type of soil it is. Now, NICS Pro color sensor device can help to change this method was been implemented before to create an accurate and precise data to find the color code of the soil. My research deals with these problem statements where, first of all, whether consider for using the color chart. As you can see, the Munster color chart must be used under ideal conditions such as sunny, clear, lightning, and wet environment, which has its limitations, and also technical issues related to the chart condition, where the faded color that does not have the same color code as the soil will affect the readings and also the data that we can obtain on the site. And third, human component limitations, which are the human aspect of soil color determination is limited by poor vision and readings may vary from person to person, depends on the specification. So I've developed my aim of this research to be to identify and classify peat soil using color code by the help of NICS color sensor and to standardize a proper method to use the NICS Pro color sensor. And the objectives for my that I get from my aims are standardize a method by using NICS Pro sensor for peat soil classification and also compare the results with the Munster color chart to check the accuracy of the chart compared with the NICS color sensor. Let me give you a brief explanation about what is NICS color sensor. In this case, for my research, I am using NICS Mini 3, which is a color sensor device which is mainly used in the textile industry and a portable and compact design with a Bluetooth features which is intended in it and measures and identifies colors accurately. It can provide color codes such as RGB, CMYK, hex, and lab color values. For this research, I've developed a coding in Excel spreadsheet whereby I use the NICS color sensors color code and compared with the Munsell color charts color code to the nearest accurate value as possible as it can. At first, I visualized the color and I created a coding for the color that we can see in the Excel spreadsheet. This is the code that I use in encoding into the Excel spreadsheet for the visualization color. For the next step, I have developed an code for the nearest to Munsell color chart color value in DRGB and also to get the pure chroma value from that color chart using the NICS color code which is written in the highlighted color cells yellow in color RGB. This is the Munsell color chart which is converted into the DRGB values which I've obtained it from the Rochester University of Science where it is published publicly to be used for researchers and for research like this. Finally, I've developed a code that to get the nearest Munsell color chart color code with the NICS color sensors color code and also I've also developed a formula with get the accuracy of the color code matching with the Munsell color charts color code. Now on to the next step where I have developed a standardized method using NICS color sensor. For the first step, with the NICS color sensor should be connected to the power supply to switch on and the red light should be flashing on the lens below it. Make sure the lens NICS color sensor has enough battery to be used on site. For the second step of the standardization method, we need to install the Nix Toolkit application through via Google Play Store or any other mobile application that can be accessed to get this app. After installing this app, the Nix color sensor should be connected to the Nix Toolkit via Bluetooth accessory. Take some sample from the site and put it into a platter where it should be spread evenly, and the Nix color sensor should be placed on top without any gaps located below it, because the Nix color sensor will create a black environment emitting a light on its own to get the accurate color code as possibly as it can. For the fifth step, the Nix color sensors Nix toolkit app, we need to click the single scan to get the color code in the app. After clicking the single scan, the color code will once show on display in DRGB and also in hex and CLAB color code. For our main focus here, we are taking the DRGB value and needed to be put in the Excel spreadsheet. So repeat these steps for 4 to 6 times with different points in the soil sample to get the average value of color code for that soil. Once collecting the data of the color code of the Nix color sensor, we should put the data in the highlighted yellow cells with RGB in, and it automatically gives the value to the nearest month's color chart color code and also states the accuracy and the minimum error of it. This is the flowchart that I've created throughout this research, where at the same time when we are using Nix color code color sensor, and we need to get the laboratory test results to compare both of them to classify what soil is it. Now let's look at the results and analysis that I have obtained through the color codes of the Nix color sensor. From the results obtained from the laboratory test, it is stated that soil is not peat soil and it's organic soil with high plasticity and has the moisture content 152.33%, and because it is classified as not peat soil, which you can see at the organic content where it is 25.3% at that, because we need 75% and above to consider it as peat soil. So the first color code classification is whereby we take the fresh soil out of the site and we have taken the color codes and later on the moisture content test, and after that we have gotten this result as shown in the figure, which where we have done two, which is sample 1 and sample 2. As you can see, the fresh color code was from the site was darker compared to the moisture content test. Afterwards, it is oven dry batch where the color is brightened up, causing the RGB from the first to the second is risen. For the second test, we have conducted the Nix color sensor color code testing on the standard proctor test where we have used it for sample 1 and sample 2, and we have get the results where the RGB value decreased from that 10% to the 40% mark, and later on it increases 40% and onwards above that, where it shows that the optimum moisture content where it has the darkest color as possible as it can. So the final analysis that we can get overall is whereby the optimum moisture content of 36.39% is the darkest color of color code as much as possible, and it shows that at the dry density of 1.09 grams centimeter per cubic has the darkest color, and overall it concludes that it has the organic content which is presented in it. This is the summarized version of whereby I've collected where the fresh soil samples color code from the total where which is the consistent value that we have taken from the Excel spreadsheet, and also the moisture content test, standard proctor test of one dry sample, and the optimum moisture content test. Each of the tests shows different values and different Munsell color chart codes value, and also the accuracy never drops below 90% and is always high. So the final analysis for the Nix color sensor color code classification is whereby the pecan soil is classified as organic with high plasticity, not meeting the peat soil criteria. Experiment indicates that organic soil with a clay and silt mix organic content meeting the criteria for organic soil should be more than 25%. Plasticity and the optimal moisture content values don't align with the peat soil standards. So the conclusion that we can get from overall from this experiment is whereby the soil is organic with high plasticity and not peat. Fresh sample from mixed color shows that the 5 U and 2 chroma and 2 value with the 97.27% accuracy, highest value recorded. And the moisture content test is in the Munsell color chart of 25 year Hua, 3 chroma and 2 value with 97.42% accuracy at 0% moisture content after oven drying, which is oven dry. Standard proctor test indicates the color code of 2.5 hue, 3 chroma and 2 value at 98% accuracy for 0% moisture content, uncertain for the dry sort. The darkest color that can achieve is at the optimal moisture content, that is 2.5 hua, 2 chroma and 2 hua. 97% accuracy in 4 out of 8 samples where it's consistent value that we have proven and get. In conclusion, we have achieved both objectives whereby the NICS color sensor accuracy has shows the most effective way to match with the master color chart's color codes accurately, where the darkest color code 2.5 pure 2 chroma and 2 value has correlated with the color code from the Mansell color chart, and also the standardized method of NICS color sensor shows that it can get the most accurate color code as possible as it can. For recommendations, first of all is for testing for peat soil resiliency. In this test, we aim to get peat soil by the end. Eventually, we applicating organic soil with high plasticity. So we want to suggest that we use these tests to do with the peat soil. Second is color sensor calibration, where we want to emphasize the importance of regular calibration of color sensor like NICS system to be encoded into the field of engineering. And third of all is database integration for precision, is whereby we want to use the NICS color values to comprehensive parameters, aiding precise analysis, improving the sensory accuracy overall. That's all from me, and thank you so much for listening through this presentation with me.